Okay, so let's see what we can do for today. We will not keep long. By way of revision, we installed the Anaconda package. The Anaconda package helps us to easily set up our coding environment, especially around Python. And we briefly introduced ourselves to the Anaconda Navigator interface, which basically has a lot of tiles, and each tile points to a particular application. Most of those applications there are integrated development environments. Example is Jupyter Lab, Jupyter Notebook, Spider, PyCharm, and the rest. You can explore all of these things, and exploring them is not difficult. Exploring them is just a palm away from you. You can use your phone to go to YouTube and find some video on how to use PyCharm, for example, how to use Spider, for example, as an IDE. So that can help you to know at least the popular IDEs that you find on the Navigator, Anaconda Navigator. We also learned other ways to actually open your IDE of choice. For example, Jupyter Lab, that's what we're going to use for most of our sessions. We said you can use the Anaconda prompt, which is not the same as the Anaconda Navigator. The Anaconda Navigator is it's an app, and then loading the app, it's usually very sticky, especially for those whose computers might not have a lot of resources. So Anaconda PowerShell prompt, it's a command line tool, command line interface. So when you open it, I hope you can see the command line open. If you can see it, let me know.
Yes, sir.
Yes.
Yes, please.
So with this command line open, you'll see that you have, it's maybe tiny on your device, but basically the writings you see here is the path where anything you create using this CLI, command line interface, the path or the folder, the directory where it will go and deposit. So you will see C, that is on my drive C. Inside drive C, there's a folder, big folder called users. Inside the users folder, there's another folder called CodeFusion. So that's where it will go. So when I open Jupyter Lab, for example, I just type Jupyter Space Lab. That's the name. If you want to use Jupyter Notebook, you just type Jupyter Notebook. If you want to use Spider, you just type Spider. So when I do this, it is going to open an instance of Jupyter Lab, and the file, the Jupyter Lab file, will be deposited in that directory, in that folder I just showed you. This is less graphics intensive if you compare it to opening it from the Navigator. So you can, of course, preferably this is easy, and this requires less resources to be able to open your application. So you can also use this one to do that. But you need to remember that when you open the application at this directory, this is where it's going. That also means that if you want the Jupyter lab file, the notebook file, to be opened in a different folder, in a different directory, not Kofiado in this case, then you first of all needs to change the directory. So I'll share, today we are not going to do that kind of exercise. I'll find some nice video on how to navigate yourself around the CLI, the command line interface, how to change your directory, at least basically what we will need to help us to do what we want to do. So I'll send you a video and maybe we'll do some tutorial on that. But in the meantime, this is one way you can open your application, Jupyter Lab. We also talked about another programming environment, another integrated programming environment, not for exclusively for Python. Jupyter Lab happens to be an exclusive application for Python usage. I have not really known other programming languages that we can code here. It's for Python, it's for IPython, interactive Python. But there's another coding environment called VS Code, Visual Basic Code, shortened as VS Code, manufactured by or developed by Microsoft. And I think it's the industry's choice that most people use it. Most people use it because most people do more than Python. They do Python, they can do other programming language like JavaScript, Java, they can do. It's very versatile such that you can program different languages using the same kind of environment. So we also we learned how to install it, and we learned a few things about how it works. When we get to the section on web development, that I'll switch to the VS Code for us to understand how the environment actually works. So today we're going to follow up on where we ended. Basically, this is what we did for the first week. So we're going to build on it. What I'm going to do is that quickly, we are going to talk about some of the things here in week 1. What it means is that what we did in week 1 was actually not week 1. That's what I'm saying. We're going to cover all the things here, but we are not going to follow it structurally as we have it here. So today, week 2, this is what, so maybe I'll have to modify this and reshare it. Week 1 was something else. So week 1. So this will be week 2. Week 2, we're going to talk about some of these things. Overview of programming, coding, why learn to code, basic concepts. We'll run through these things. For those who are already okay with these things, you can still stay around and help by your contribution, help those who are picking these things for the first time to also learn it quickly. Learn it in some enjoyable fashion, right? Because it's actually fun to do these things. And for those who are kind of learning programming for the first time, these things are very cool. You do them every day. So use everyday scenarios to explain how you can do the same thing you do every day using programming approach. Even though they are the basic, these are like very basic building blocks of programming, they are actually the foundational elements in programming. Without these things, like week 1, week 2, week 3, at least up to about week 5, without these things, you cannot do any programming. Even though programming, when you look at a typical code behind some application that you use on the web or on your computer, if you look at the code structure, it will be very verbose, very complex. It is these things that we combine, we mix together with other things to do those kind of things. So these are the fundamentals without which you cannot build. You need to get these things. So today we're going to talk about them. But I'm going to infuse something small into this. So you have to pay attention. This is our notebook. So let me open a fresh notebook. And to open a fresh notebook, you see this button here, plus button. So all of these are instances of notebooks. EOQ to share, Untitled 6, Untitled 7. When you open a notebook, the default naming is Untitled and some number based on how many of the Untitled notebooks you have created in the same directory. So when I do another one, it will be Untitled 8. So this is how you do it. You click on that plus and it brings you this window. You have two options to create a console or open a console or open a notebook. You're going to do notebook. You can also do other stuff like terminal, text file, markdown file, and so on and so forth. So this is what makes this one a lab. If you open the classical Jupyter notebook, I think you'll basically see one thing, maybe this notebook, or maybe notebook and console. You will not see other stuff. So all of these things are here to make it a lab. So you can stand here and do all the sort of things. If you want to really program using a terminal, you can easily click one and do so. We're going to do notebook, so I click on notebook. Okay, so at the location where I find myself, Untitled 1 is there. So it just gives me Untitled 2. And you see that the new window, the new notebook opens in a tab like this. And I can rename it quickly by right-clicking on the tab. And in the menu, you will see rename notebook. So I will just say CodeFusion, say week 2. Okay, so it's renamed. Now let's talk a little bit about the interface for the notebook. So we are doing this because we are assuming that we have newbies. Majority of you may even be newbies trying to pick up on coding. So we have to be picking things from the scratch so that everybody will be able to follow up. If you already have these things, if you're cool with them already, no problem. You can just use the session for revision. So I've already talked about these tabs. These are instances of your notebook. So this is the current instance of the notebook as we are working with. You can also see that we have these menu items here. We can have file, edit, view, run, kernel, tab, setting. Each one has specific tools that you can use in particular circumstances. For example, the file, you can click new instead of using this plus. You can open from path. You have a lot of things here, so let me just go to some of the usual things that may require you to come here. maybe download if you want to download the notebook. Rename notebook, you can also use the file menu to do that. Saving the notebook and stuff like that. So you can come here and do that. When you go to edit, you will see paste cells, copy cells, split, merge, this kind of stuff. View, this one is about appearance, simple interface, presentation mode, show left sidebar, if you fancy showing the left sidebar, show left activity bar, show right sidebar, show many things. So just experiment with these things and see how it plays out. You just stick with the one that makes you feel okay. Run. So usually you have to run the code, run the notebook. So run selected cell and insert below. Run selected cell and do not advance. So many options for running your cells, your code cells, or your notebook. So we also have kernel. So in the meantime, understand the kernel as what makes the notebook run. So what is running behind the notebook? So this notebook, as I'm working on, is being run by a kernel. So you can shut down the kernel. So let's say now I have this notebook, this notebook, this notebook. All of these things are underpinned by kernels. So I can shut down a particular kernel if I'm not using that kind of notebook. I can shut down all kernels if that is appropriate for me. I can restart kernel and run all the cells. Sometimes you do this if, for example, you see when you start coding, the coding are done in cells. So you have cell numbers. Let me show you this one. So you have cell numbers. So this cell is cell 1, cell 2. This one is cell C, cell 57. So it doesn't follow chronologically, which sometimes is not the best. So if I want to, maybe I'm done with this coding. I'm done with everything I wanted to do. Everything is fine for me. In the process of building the application, building what you are building through the codes, it's usual for you to see these kind of unchronological cell numbers, like 2 to 57 up to 60, 63. They don't follow. So what you can do is that you can come here and say restart the kernel and run all cells. What it means is that it's going to behave as if you are not going to be beginning the code, and it will now do them very sequential for you. So let me just do that and let's see the effects. So it's going to restart it, and when it restarted the kernel and run also, you see that you see 1, 2, 3. So this 3 is the output for the code cell 3, so it will repeat the 3. 4, this is the output for the 4. 5, output for the 5. 6. So that's where it will be necessary for you to do restart kernel and run all cells to just kind of shape things up. Tabs. So you can go through here and see what the effects will be for you and where you want to be for yourself. I don't really come and navigate things here because I don't really use the stuff here. Settings, theme settings, can come here and tweak few things. Maybe if you like a dark mode, yeah, this may be cool for those of us who like dark things. You can do dark light contrast, lights. So that's about theme. Language, I think it's English, auto save. You can make certain settings here, auto close brackets. This is very important. For Jupyter Lab, unlike Jupyter Notebook, the classical Jupyter Notebook, auto completion of brackets is not automatic. So you can come to settings and check here, auto close brackets, so that when you do something like this, let me go to this cell. When I do something like, okay, my lists equals, then I want to create a list. So I open square brackets. The closing comes automatically with it, and you just type. If you don't come and do this checking, auto close brackets. So let me uncheck auto close brackets. And let's do it again. Okay, so once I've unchecked it, I pressed on open square brackets, and only open square bracket comes. It means when I'm done, I need to do closing myself, which is boring. We don't have the time to do that. Automate it, so auto close brackets, and when I do open, the closing comes automatically. When I do curly braces, open and closing comes automatically. When I do parentheses, open and closing comes automatically. When I do quotation, open and closing comes automatically. To speed up your coding process and also to make you get error-free code, error from these kind of brackets, quotations and stuff. Okay, so you can play with these things. We have run ourselves quickly through it, but get a time and play through it. Your machine is not going to spoil. Play through it. Just follow what you are doing so that you can know exactly what each of the things you are doing is producing, and whether you like it or not. You can, for example, I just came to things, and I really like dark things, so I changed it to dark. That's all. If I don't want it to be dark, maybe I can change it to any one of these things. So maybe this one. This one is a different dark mode. And if those guys who don't like dark things, maybe you can do this. I'm still going to go back to dark. Right. So that's it about it. And here you can also, this is the main window where you will see your workflow. But we also have other spaces here, like here. When you click here on this folder button, it shows locations where your files are. So you can see all of these locations. All of these things are folders in the main location you find yourself, the folders that you can find there, including the files that are in that location. When you come here, this kind of, it's like stop play button sort of. Here, you will see all the running kernels. So you can see all the kernels that are running here. We have EOQ to share, that's this one. If maybe all of these things, once they are running, one thing is for sure, they will take resources from your system. What if you are not using it because you open it previously, and once you open a notebook file from that location, it will kind of show all of these tabs automatically. That's the behavior. So I don't really need this and this and this. When you close this, for example, well, you have closed it such that you are not seeing it as a tab. But the kernel that runs that file is still active. So what I closed was Untitled 7. It's still here. The kernel is still running. When I close this one on title 6, the kernel is still running and it's still using your resources. So this is not the best way to close it. It doesn't work like your word processor, Office Word, where if you close the window, all the files go back and sit on your hard drive. They wipe out of memory. It's not like that. If you close it like here, it's still running, the kernel is still running. So you can kill the kernel here, you can close the kernel here. When you come, you click here, you see all the running kernel. So if I want to kind of close the kernel, I can come here and say close, close. And here it is actually closed and things are wiped out from memory. Here looks like it's going to populate some lists. Actually going to show you something like the outline. So let me see this. Okay, so the markdown, we'll talk about markdown briefly. So the markdown sections of your notebook, you see these kind of annotations. So that's the outline it tries to create. So I can click to navigate quickly through the notebook. That's basically and this is for maybe other extensions that you can install. Yeah. So basically that's how these areas also function to help you do your coding. I'll share with you some easy to understand tutorial on Jupyter Lab so that you can go through them again and get your knowledge more solidified. So now let's come to here and let's learn about what goes on here in this space. We have learned about the general environment like these menu items, like these other tabs here. All of them are set up to help you find it easy to do your coding. Now, when you come to the working area, by default, you'll see something like this, like a space. And then when you click on it, your cursor blinks. So this is a space you can type something. But what we can type in Jupyter Lab are basically two things, even though there can be more than two, but the usual things we usually type is two things. And let's see these two things. When I click here, when you look at here, this buttons here. This one is for saving what you are doing. This one is for inserting a cell below. So if I want to insert a new cell, by default it comes with one cell. I can click on this plus. There's another cell. I can click on plus, 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 plus. Maybe I have a structure I am working with. And I pre-know the structure that I will need maybe these number of code cells. I'll talk about what a code cell is briefly later. So I can use this class to kind of preload the cells that I'll be using, like I've done. This one is cut a cell and maybe put it somewhere. This is copy a cell. This is paste a cell. This is run a cell. This play button. This is interrupt the kernel. Maybe like pause or stop the kernel, sort of. This is restart the kernel. So you can do all of these things through these buttons instead of coming here and doing those kind of stuff. And this is restart the kernel and run all cells, like this one. Restart kernel and run all cells. This is the shortcut button, so double play button here. But what I want to really talk about is this, because I was explaining two basic things that happens in another way. You can also add a cell is when you see these two buttons. So this rectangle is it symbolizes a cell, because the cell is actually rectangular. So when you see rectangle and then there's a plus on it, it means I want to add a cell. When you see it and it's like, okay, when you see it and let me do it again. When you see it and we have a plus on top, it means I want to add a cell above. If you do the one with the plus below, you want to add a cell below. This is to delete that particular cell. This is to move the cell up. So let me type something in and move it up. It is moved up one cell, moved up again, and I can move down. Yes. So that's how you can also use this. And I can also copy, duplicate this cell. So that's what this one means. So let's talk about the two things that happen here. The IPython project, based on which the Jupyter Notebook and the Jupyter Lab are created for coding, is based on the ideology that coding should be very flexible, and is also called a notebook because look at a typical notebook, the notebook that you bring to class every day. You write your text inside. If there is some calculation you need to do, you do it inside. Some explanation on the calculations, you do it inside. That is the same philosophy that notebooks or Jupyter Notebook or Jupyter Lab carries. So I can do my calculations, which is the code here, but I can also write explanations based on the code. For example, if I do something like, let's say import, don't worry about what I'm doing if you don't understand. Import, let's say pandas, or let me just use an existing notebook where I have something, right? So let's say I have this. I have this output, which is a diagram for economic order quantity. So we have modeled it, we are showing this picture. And I need to provide explanation. So all of these things are code. This is a code. This is a code. This is a code. This is a code. So we have code cells. We can have two main cells. When you click here, you can see the various cells we can have. We can have code cell, we can have markdown cell, and we can have raw cell. I have not really used the raw. Basically, you will use code and markdown. The markdown is like your word processor, where when you run the code, you want to provide some explanation on it, you can open your word processor, sort of, inside the same notebook and write it. Right. So here, this is a code that I have run and gotten this. If I want to write some explanation on top of this diagram, I'll write it here. By default, the cell that you see by default when you open a notebook, or any cell that you add later, like this, all of them are code cells by default. So now if I need this cell to turn into some word processor, which is also called markdown cell, then I have to come and change it to markdown cell. And markdown it means the cell is ready to receive text inputs, run as a text, not run as a code. For example, if it is in the default code cell and I type something like, okay, this diagram depicts the concepts of economic order, quantity modeling. Yes, it's text. I want to provide a textual explanation on the graph. But since I'm typing it in a code cell, when I run, it will show error because the program understands that because we are in a code cell, it interprets this as a code. And it looks at the syntax and it said, what is this guy trying to write? I don't really see this as a code. There's nothing about this structure that resembles the syntax of Python. So it says invalid syntax. So you change it to Markdown because that's what we wanted to do. And when I run this, you see, okay, it's cool because the cell type you've chosen understands that, okay, we want to do this. But there's more to just typing a text. For example, let's say I wanted to add a heading before this text. So a heading like, so I first need to change this one to Markdown. And I want to provide a heading like, okay, interpretation of the chart. Interpretation. Interpretation is okay, right? Usually you want this interpretation, let me run, to appear bolder because it's a heading. Markdown, the reason why we call it Markdown is that we use some characters to mark what we are typing for it to be formatted in some ways we want it to show. For example, I want this to show as a title. So in a Markdown cell, when I do this pound symbol or hash symbol like this, hash symbol space, then what I type. A single hash symbol, the hash symbol is for title cases in Markdown cells. So when I run, yes, now it interprets what I am writing as a heading because that's the meaning of this symbol. If this is too big, when you do 2, you step it down a bit. What if I wanted to really do these things as bullets? I can do as bullets, I'll have to do like this. So space, then you type hyphen space. So let's say 1, then I come to next one. So I'm doing something like typing the interpretation in the list form. Forget about what I'm typing. I just want to show it as a list. When I run, it will show as a list. So I'll share with you some tutorial for you to quickly learn how to do this kind of markdowns. so that when you are doing your notebook, you can provide neat, nice interpretations to it. Through the Markdown, you can even write some nice formulas, mathematical formulas, so that it show up like the way we do it in normal mathematics. So I'll share that video with you. So let me pause. I've been a bad teacher. I've been talking without asking whether anybody has a question. Let me pause and ask any questions so far.
Yeah, sir, please, good evening once again.
Yeah, good evening.
With the kernels, when
Yes.
we close a tab and the kernel is still running, can we reopen the tab by just, clicking on the kernel, which is already running?
Yeah, so experiment it and see. Let's say, let me come here. I have 2 kernels running.
Okay.
Let me close this. Okay. The kernel is still running, EOQ to share. Right click. It's always good to right click to see the menu, whether what you want is there. Save page, select all, blah, 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 view page source, inspect accessibility, log into. So it seems not to be there, but when you double click, it will open.
Oh, okay.
Yeah, when you double click, it will open.
Thank you so much, sir.
Okay. Any other question? Okay, so now let's quickly go to the outline and quickly do something. These things on the outline are very basic stuff, so you're not going to. Okay. Overview of programming. Programming basically is a way of talking to the computer. Basic idea we can pick is this. The computer as a tool is very powerful. It has a lot of speed, processing speed. It can do things with much speed than we can do as human beings. And sometimes it also does, especially with routine things, it does it with much accuracy than us. The computer is actually powerful. Even just look at your personal computer, which has some good resources. It does some quite good stuff. Now compare it to a mainframe or a supercomputer, and you begin to see how powerful the computer is. And just imagine the things that computers help us to do. Look at the weather. Look at firing space jets to the space. All of those computational calculations, a lot of things. Look at artificial intelligence. All of those things are computers. Computers are powerful. And therefore, we need to use computers in our everyday life. Certain things that we are not able to do well is because we don't use the right tools. And those who use the right tools to do them always get the upper hand, the advantage. The way to use the computer well, effectively, is through programming. Because the computer does not know human language. So I cannot talk to the computer like I'm talking to you for the computer to understand. I cannot also type to the computer like I will type a letter and send it to somebody. No. The computer doesn't understand our language. The computer has its own language. I'm yet to read more about the magic behind ones and zeros, the binary system. The computer understands everything from the perspective of 1 and 0. It doesn't understand text. It doesn't understand the decimal system. It only understands the decimal system in its binary system. So programming is a way that we communicate with the computer. So the programming languages that are created and we have to learn are some sort of interpreters between us and the computer. The computer understands ones and zeros, low-level language. We understand our language like I'm speaking. So a programming language like Python will sit in between ourselves and the computer. So take our human, so if you look at Python syntax, it mimics human language, but it's also cool for the computer to be able to grasp and translate it into its language. So we need to learn programming language before we can speak with a computer and get the magic from the computer. Coding is just typing or speaking with a computer in the way that the computer understands. And I don't think I need to repeat myself to talk about why we have to learn coding. All of us know the magic that coding is doing. A typical example is artificial intelligence. Everything you see there, it works like magic, right? Everything that happens behind the scenes are codes. Look at web development. You have some application, you like some game, you are playing the game, you see the game, human beings or some toys or some cars. All the things working behind the scenes are not the cars you see, are not the real things that your human eye sees. They are codes. And for us to be able to do these things, because those are the things that are running the world, we don't have any choice than to learn how to code. Learning how to code should be something like playing. Okay, we shouldn't take it that hard, as if you're going to kill yourself. No, play with it. The beginning might be a little bit scratchy, but it even depends on how you get introduced to it. It's not that scratchy. But as you play with it, you grow to love it. It's cool, not difficult. In programming, as a way of communicating with a computer, there are basic building blocks. They cut across all programming languages. So we'll talk about these basic concepts briefly. Variables, data types, and operators. And maybe we can use these concepts to combine and write and run a simple program. This today is going to be Python. We can do similarly for programming languages like JavaScript later. So let's do something small. These are all repetition of what some of you already know. And we also have some people who are here for the first time. So let's give them the benefit of the doubt. So let's go to our notebook. Here. This is a code cell, and you'll see it here, code. If you change it to Markdown, you will see it here, Markdown. It's a code cell. So maybe I want to be very methodical. So here, I'll provide some explanatory or some heading. So I'll turn it into Markdown and do, okay, basic building blocks of program. And then I can come to inside the code cell too, you can provide some textual guidance. We call it comments. In Python, in a code cell, if you want to mark some writings as comments so that they don't run as a code, you precede those writings with a hash symbol. So you should be able to know the difference between how the hash symbol works in a markdown cell and how it works in a code cell. In a markdown cell, the hash will format this text as a heading. In a code cell, it will format the text as a comment, which tells the Python interpreter to skip, to not include it as a code. So for example, I will say, okay, let me go back and look at variables, data types. So let's talk about variables. So I'll take, okay, variable. So this is a comment that is telling you, the programmer, or your collaborators, that these things are about this comment you have put there. And this hash symbol in a code cell, which initiates a comment, is for single line comment. So what if my comment is so wordy and it will span more than a line? You can break them and probably do them multiple single lines, but that may not be nice. Another way to do that is you can use triple quotation marks, 1, 2, 3, and then put. So because I have auto close brackets, so when I do 3, the closing 3 also came, and the cursor will find itself in the middle. So you let me delete all of them. So 1, 2, 3, then the cursor is in the middle. So 3 opening, 3 closing. Then let's say I'm going to type something lengthy. So this is for experimentation on variables in Python. Python is cool. All right. So when the text, of course, I can even drop this one and make all of them, make all of them structured like this. The structure is your own thing. Now I have triple quotation opening, triple quotation ending, and everything is inside it. So that is marking the text, and it marks it out as a comment. So when I run, it will not interpret this as a code to give me, so I can run this. It will not interpret it as a code to give me an error. And you do this to provide a lengthy comment, multi-line comment, if it becomes necessary. So I can do this and now probably come to my code and say, okay, my list, for example, is equal to 1, 2, 3, 4, 5. Okay. So you see, it will run this code. This is a code. This one is a comment. It will read this as a comment. It should not be run as a code, but it is guiding us to understand what the code is. So this is in code cell kind of text, and it provides comments on the codes we write. This is multi-line comments put in triple quotation. If it is a single line comment, the hash symbol is used for that. Now let's talk about variables. Programming is procedural, even though we have object-oriented programming. Most of the time, your programming will be sequential. Some code running from the top, producing something which is used by the code below it, passing it on and on and on and on like that. So it's that procedural. So variables become very necessary. Variables are the containers that we use to collect what needs to be passed on to the next stage, and so on and so forth. And variables are very basic. Variables are containers. So let's say I create this. This is a variable. It is also called identifiers. So this is a variable, my lists. And then what is inside that container? So variables are containers. Is this thing. And it also provides a way to store stuff which needs to be used later. So I have my lists. I can have my list 1. That's another list, and it is, let's say, 10, 20, 30, 40, 50. I have stored all of these things in some containers. In the process of programming, you might need to use some of these things. You just call them by their container names. So it is also very important for you to be mindful of how you label the container that holds the content you are storing. So that is to say, how you label your variables. Your variables need to be named in an explanatory way, and also descriptive way. What I mean by that is your variable, the way you have named it, should tell everybody, including yourself, about what is inside that container. It should be descriptive. So if it is about student scores, you can't name it as, let's say, X or Y. Later, when your programmings are plenty, or when another person needs to collaborate with you, the person will struggle to understand what X represents. But if you had named it student scores, it speaks by itself. And there are also some other rules that you need to observe in creating variable names. Your variable name can never begin with a number. It can begin with an underscore, a letter, but not a number. Numbers can be found in between. That's not a problem. It should not begin with it. And you can also write variable names with spaces, like this, my space variable, like the way you usually work in word processor. No. The reason is that when you type this, once a space comes in between, the program interprets this as one variable and this is another variable. So if you mean that you are creating two variables and then you say equals, let's say 10 space 20, let's see if it works. It doesn't even work that way. I was thinking this can be assigned to this and this can be assigned to this. It doesn't work that way. So usually what it means is your variables cannot have space. Programming doesn't work with space, actually. So you can write in a way where your writing can still be legible as if they have spaces, but without spaces. One notable way Python writes, or programmers in Python write to avoid spaces and still make the thing readable, is to use underscores. So the underscore is a Python thing. Python uses it a lot. JavaScript uses what is called camel casing. So it would have done it something like this. My variable. So you see that because this one begins with capital V, it makes the two words different, but it's still written together. Python's way of doing it is this this snake casing. Snake. So my variable I have created. What makes it called snake case is that if I should draw a line on top of what I've written, it will be something like this. So it will come down and come and write over the underscore, come up and write on the V and all of these things, come down. So anywhere we have underscore, it comes down. And then it will be kind of doing the shape of when a snake is moving. Snake casing. That's all the idea. The camel case is, the camel has that kind of protruded back. So when you do something like this, my variable. So this is, and you draw a line on top of it. You see this, and here will, where the capital S will raise up. So that's the hunchback at the back of the camel. Camel casing. That's the idea. We pick these things from nature. That's the idea. So let's say I later I'm doing something that requires me to combine these two variables. And that's the reason why you always have to be creating variables. Variables are basic building blocks of programming. The reason is if I have to use this series of numbers 1, 2, 3, 4, 5, subsequently in my coding, I do not need to write 1, 2, 3, 4, 5 again, 1, 2, 3, 4, 5 again. You store it in this container and you refer to the container. So now if I want to do another variable which combines these two, I can say, okay, this should be my list plus my list 1. So what basically this is going to do, this plus is going to do is it's going to concatenate. It's going to join them together, right? So let's see when I do my variable, what the feedback will be. Okay, so you will see that my variable, which is created as concatenation of the two previous lists variables, is now going to be 1, 2, 3, 4, 5, 10, 20. It's concatenating them. But just think of it like if there was no this variable creation or this concept of variables, and we had to create a new variable that combines these two sets of numbers already, but we don't have these containers that we can easily merge. Now we have to create these numbers 1, 2, 3, 4, 5 and add them to this. This will be a headache, right? So this is one of the basic usages of variables. And The point is you will use variables everywhere. The programming is a combination, structuring, combining, manipulating variables. So you always be creating variables. We will deal a lot more with variable manipulations when we get deeper into the programming. So let's quickly look at the other stuff and then we can close for the day. Data types. Computers are very careful. They are very particular with the kind of data that you give them. They are very particular. They interpret data strictly. They don't work like humans where we can understand, okay, well, this is a mistake, but we understand why you are speaking. We make grammar mistakes every time when we are speaking. As I'm speaking, I've made lots of grammar mistakes, I'm sure. But you largely understand what I'm trying to speak, even though there could be some grammar mistakes. Computers are strict. They don't understand mistakes, no matter the magnitude of the mistake. So that is to tell us that when we are typing, even the way we type, we should be very deliberate such that we don't make mistakes. And sometimes what to save you is to copy and paste. If you look at our notebook, for example, instead of retyping my lists and my list one, I just copied them and pasted them. That's one way to avoid those kind of mistakes which the programming language will not give you. It will not tolerate it at all. Another reason why computers are unforgiving. Another area that they are unforgiving is when you make a type mistake. And that's why we need to look at data types, because they interpret each data differently. In programming, largely, I'm not going to be specific on Python because these things are universal. It cuts across all programming languages: R, Python, JavaScript, Java, VBA, all of them. There are issues of data types, variables, operators. So once you know this, you know it for all of them. Data types in Python, and not only Python, it cuts across. We have things like floats. We have things like ints, and they are things we know already. You see, in everyday life, the data we produce, whether we are writing them on a sheet of paper or typing them in a computer, whatever, they are largely texts, like alphabets. If you have to group them, two main things: alphabets and numbers. So that's how you can look at data types at that broader level. Numeric types and non-numeric types, or character types or string types. So these are names we can use interchangeably. Let me come to the code. So numeric types, the numeric types, we can think of whole numbers. Whole numbers. There are some data when you are writing, you can never have a decimal. For example, counts. You say we are counting human beings. We are counting the number of books. We are counting anything we count. We can have 20.5 people. We can't have 13.1 books. It's not natural. So numbers come in these ways naturally. There are certain things that will always come in whole numbers. So whole number numeric type we call integers. So the code that you write, or the short form of it, that is what we really write as a code is int. Int for integer. So Python understands when you type, create a variable and you type, let's say 10. It understands that that container, because of the data inside it, that container is an int data type container. So now let's come to non-whole numbers. So floating points. That's the name. Floating point numbers. And they come in the form of things that we usually measure. Let me put it that way. It might not be that technically accurate, but we still can pick up the meaning. Things that we usually measure, for example, your height. We can have 6.2 meters, 6 point whatever. Temperature, we can have 32 point something degrees. Those kind of things that has decimal readings attached to them. There are certain things in nature that their measurements kind of produces these numbers, something point something. Those kind of things will be stored as floating point variables. So for example, I create a variable called number of participants. Today's participants, let's say 10. I create another one. Hours, or let's say duration. Hours of engagement. So let's say we use 1.5. 1.5 hours. We can run this code cell. The variables are created. Now you see these things will not cause a mistake because they are commented out with this hash symbol. So now when I do this, when I call for this and run, it will show me the content is 10. When I call for this and run, it will show me the content. It's 1.5. Now let's look at the data type. The way we can check a data type. Python is dynamic type programming language. You do not need to beforehand declare or specify that, okay, this is int and this is that. It automatically reads the data type based on what you have typed. But you can always check the type by yourself as well using a function called type. And it's so easy to remember because you want to check the type, the data type of a variable. The function to help you do that is called almost the same thing, type. So when I do type, and being a function, every function has open closing parentheses. If I pass this through the type function and run, it tells me the type of this variable. It says it is float, hours of engagement. And when I do same type and pass number of participants here, it says it is int. What if I type something here, name equals, and this is one thing you have to note, for non-numeric variables, you always have to put them in quotation. A computer can easily understand numbers, but it finds trouble in understanding character right away. If you type characters or numbers, it first of all reads it as a number, and if it doesn't see it as a number, it will throw error. So if I type something like this, name is, let's say, Kofi, it will read this Kofi as a number. If it is a number, it is cool. If it doesn't see it as a number, it will kind of say, what is happening? Name Kofi is not defined. What it is rather thinking is, well, if it is a number, it's cool. It means that, okay, I'm assigning this number to this variable name. If it is not and it is a character, then it is thinking of it like another variable that exists somewhere, which probably has a value. So it's saying, okay, I've read through the notebook you are creating. I've not also seen, this is not a number, and I've not also seen a variable which has been created as Kofi. So it says name Kofi is not defined. It means it is not created as a variable. That's the meaning. So if it is a data type, which is string, it's text. And we'll usually be typing text in addition to numbers, everyday thing we do. If it is text, you do this quotation. Then the computer knows that, okay, this is a special character. It is text, it's not number. And it's not also a variable that has been created to hold a content. Then the computer will say, okay, fine. So when I do name, it says, okay, it's Kofi. Any questions so far?
No, sir.
No, sir,
Okay.
okay.
So let's quickly move on. These are basic concepts which are cool to understand. So this is okay for the start for variables. We'll be talking more about variables as we move along. Let's talk about operators briefly. Operators are those operational signs from our basic mathematics that we operate numbers on, or we operate, let's say, either numbers or text, because we can do text operations also with operators. So something like plus, minus, these are the basic ones. Division, raised to, all of them, they are here. Just that we need to understand a few of them in a different way. So we can have 1 or 2 plus 2. This one is an operator, the plus, which is combining the numbers in some special way. And we know what that plus operator does. It adds the two numbers. Another operator would have manipulated the numbers in a different way. For example, if we had done minus, it would have operated on the numbers in a different way. Subtract one from the other, and you get a different result. If you have done divided by, that means we want to manipulate the numbers in a different way. So that's operations, and therefore operators. If I do 2 plus 2 and run, it says 4 because this is an operator that combines the numbers in some way. If I do 2 minus 2, it says 0 because this is operator that combines the number in a different way. These ones are very basic for us to understand. 2 divided by 2 is 1.0, says 1. 2, so let's say we have these two of the same operators. And let's see. Okay. So your assignment is to go and read on the difference between this / this division, right? Division, and double of it. What the difference is in Python. It's your first assignment. When we meet next week, I'll ask before we proceed. This one gives us, okay, now 1.0, this one gives us 1. Technically, there's no difference, but let me change it a little bit. So let's see, this is 5 divided by 2. Just 2.5. And let's do the same thing, 5 divided by 2. It says 2. So you are probably getting the difference clear. They are all division, but division in a separate way. So this is another operator that divides two numbers in some special way. This is called integer division. One is called integer division, one is called floor division. Find the difference and when to use them. And let's also look at this. Let's say 2 raised to. This one is times, so 2 star 3. Star is times in programming, not only Python, generally in all programming. 2 star 3 is 6. But we can have 2 star 3, just like we have this also double. 2 star 3 is 2 raised to 3. That should give us 8. So this is how we type raised to in Python. So this is raised to operator, double asterisk, raised to operator. And this is multiplication operator. We also have, let's say 4%, let's say 2. So the percent operator, called modulo operator, returns the remainder after you divide two numbers. When I divide 4 by 2, four by 2 is equal to 2. It doesn't have any remainder. So the remainder here is to be understood as, let's say if I do 5. Let me do it 5 so that it will help us to understand. When I do 5 by 2, it will give us 2 remainder 1. So when I run this, it will give you 1. When you divide 2 by 5, it will give you 2. What it means is that I have 5, let's say, oranges. Let me try to interpret it basically. I have 5 oranges, and I want to group these 5 oranges in twos, in groups of twos. So I do the first 2, I do the next 2. So I can have 2 groups of 2 oranges, but it will be left with 1. That's the remainder. So this is the modulo operator that returns that thing automatically for you. I will send you videos on all of these things we have covered today so that you can go through them in some detail. So let me pause here and ask if there is any question. This is where we'll bring today's sessions to a close for the basic building blocks, particularly centering on variables and data types. Any questions? Okay, no questions. That's cool. So we will end it here, and I will share the recording as usual with you in your various groups so that you can have access to them. Those of us who are not able to participate can also watch them. Thank you very much for your attention. We will meet next week. Bye-bye.
Thank you, sir.
Thank you. Thank you, sir.